In this video, I'm going to show you how to find antiderivatives of a function. Now, before we do that, let's think about what do we mean by antiderivatives. Well, we know what derivatives are, right? Now we're going to do the opposite of that. So it's kind of like thinking in the reverse direction. So let's define what is an antiderivative is, and then we'll do a couple of examples too. So a function, big F, is called an antiderivative of the little f on an interval if the derivative of that function is equal to the little f. So this is what we mean by antiderivative. So when you guess this function and when you take its derivative, it should give you the little f, or this other function we're looking at. For example, so say we're looking at little f of x is equal to x squared. We want to know what is the antiderivative of this function. Well, you're kind of guessing backwards. So whatever this function is, when I take its derivative, I get back this little f of x. So that means I'm going to guess the function to be x cubed over 3 plus a constant. Now, every time you have an antiderivative, you always want to tag along this constant because it's the general antiderivative. It can always be modified with an initial condition. So I'm guessing this is my function because if I take its derivative, so check this out. If you take the derivative of this function, so for differentiation, we know the power rule. We bring down the power, subtract 1 from the power, 2 over 3, and derivative of constant is 0. So we know this is equal to x squared. Check. This is equal to our little f of x. So that's why this is the antiderivative of this function. Now, hopefully you got the idea, but sometimes it's very difficult to guess. So what we're going to do, we're going to come up with the general formula for this. So suppose you're given a function in the form of, let's say, x to the n power, where n is not equal to -1. We'll talk about that a little bit later, and we want to know what is the antiderivative of this function. So the rule is pretty much like the ones above. You want to find this antiderivative, you simply add 1 to the power, and the same power and plus 1 goes on the bottom. So that's the rule for antiderivative. Of course, we're tagging along plus c for the most general antiderivative. And this is often known as the power rule for antiderivatives. So check this out with the previous one. So if I am looking for the antiderivative of this function, I pretty much add 1 to the power, and then same power goes on the bottom. You get this function right here. So this is a formula you want to remember every time you want to find antiderivative of a function that is in this power form. Now let's go ahead and consider a couple more examples. Let's say we want to find the antiderivative of little f of x equals to 2x plus 5x squared. So we want to find antiderivatives. So my antiderivative, which I'm denoting it with big F, it's going to be, so again, this looks like in the power form. So you pretty much write down its power and then add 1 to the power, and that same power goes on the bottom. So I know my antiderivative of this particular function, it's going to be 2x squared over 2, plus now I do the same thing with this one. I add 1 to the power, so that's 5, bring it along to the third power, and I divide by that same power, 3. And then I just tag along a constant plus c because it's the most general form. And then you just clear things up. So you know your big f of x, which is the antiderivative, is x squared plus 5 over 3 x cubed plus c. And you can always check your answer by taking its derivative and check it's the original function. Hopefully this is making sense. Let's go ahead and try one more. So say you want to find again the antiderivative of the little f, which is x plus 4 times x minus 2. So for this one, we cannot use the power rule yet because there is a product in between. So we're going to expand it and then find its antiderivative. So I'm going to go ahead and expand this. So this gives me x squared minus 2x, and this is plus 4x minus 8. So my little f simplifies to x squared plus 2x minus 8. And now I can find its antiderivative. So the big F, it's going to be, now you can use power rule for each of these. So using the power rule for x squared, you get x cubed over 3. You add 1 to the power, same power goes on the denominator. Plus the second one, 2, bring it along, and then x to the second power over 2 minus 8. Now think of it as you have 8 here, x to the 0 power. So you add 1 to the power, you will get 8x to the 1 power over 1. We can just leave it like that. And then this will clear out to just simply 1/3 x cubed. The 2 cancels out, plus x squared minus 8x plus c. So that is the antiderivative of this function above. Now this is really introducing us to integrals. Integrals are a convenient way of expressing antiderivatives. Integrals are often denoted by this symbol right here. So if I put that symbol and I place this function inside of it, let's say x squared, and put dx next to it, that means I'm doing the antiderivative of this function. So you do the same thing using power rule. It's x to the 2 plus 1 over 2 plus 1, and you add plus c to it. And then this is just x to the 3 over 3 plus c. So integrals are just convenient way of writing, find the antiderivative of this particular function. And this is called indefinite integral because there is no limit right here, no limit of integration. And again, we'll discuss this later. For now, let's just practice this a little bit more. Now let's say I give you another function. Let's integrate or find the antiderivative of x to the 4th minus 3x squared divided by x dx. Now, I cannot simply use the rule that we wrote down. Let's write it down one more time with integrals. So we know the power rule for antiderivative is simply if you have x to the n power dx, then you add 1 to the power, and same power goes on the bottom, plus a constant because it's indefinite, where n is not equal to -1. If it's -1, we have a different rule. So that's the rule we want to use here, but it quite doesn't look like that. So we want to make it look like that. I want to split this up. So each of these terms on the numerator can be divided by x. So this is the integral of x to the 4th over x minus 3x squared over x dx. And you simplify. So you have the integral of x to the 4 over x, that's just x to the cube, 3x squared over x, that's 3x, and times dx. Now we take the antiderivative of each of these functions using that power rule. So for x cubed, that is x to the 4th divided by 4 minus for 3x, it's going to be 3x squared divided by 2. So I use this rule here. I add 1 to the power, same power goes on the denominator. Because this is indefinite, I tag along plus a constant. So that's the antiderivative of this function, or the integral of this function.